Welcome to this video lecture on the subject Basic Electrical and Electronic Circuits. In this lecture, we are going to discuss about Unijunction Transistor. So let's see the need for UJT. So it is required for generating the pulses in electronic circuits. So it is basically a triggering device, or it is used as a controlling switch. It is used in timing and triggering circuits, commonly used in SCR triggering. So what is mean by unijunction transistor? So it is a three-terminal semiconductor device which consists of only one PN junction. It is used as switch or triggering device. It cannot be used for amplification purposes. So it consists of emitter and base, which is base 1 and base 2. So let's see the construction of UJT. So it is a semiconductor device which consists of N-type silicon bar with two base terminals, base 1 and base 2, and one emitter terminal, which is a P-type semiconductor. So one PN junction is formed. So P-type material is alloyed into N-type bar. So the symbol consists of one emitter and two bases as B1 and B2. It is shown in this diagram. Let's see the principle of UJT. So when we are applying a voltage between base 1 and base 2, initially the interbase voltage is formed. So this resistance between these base 1 and base 2 is controlled using the applied voltage. So when the emitter voltage increases the peak voltage, so the device turns on, and after that it exhibits the negative resistance region. So after triggering the device, emitter current increases rapidly. So this can be used to generate the sawtooth waveform in relaxation oscillators. So let's see the VI characteristics of UJT. So it consists of three regions: cutoff region, negative resistance region, and saturation region. So when the voltage is increased from the minimum value to peak point value, so initially it is in cutoff region, so the device will be in off. So after it reaching the peak voltage, the UJT turns on, so it reaches the maximum value. So after that, current value decreases, which forms the negative resistance region. So and after valley point, it enters into a saturation region. So it can be used as a controlled switch, and also it is used to generate the sawtooth waveform. So UJT relaxation oscillator, the circuit consists of an unijunction transistor with three terminals and biasing resistances. So it produces the non-sinusoidal waveform. So as shown in this diagram, capacitor waveform and sawtooth waveform is shown. So the voltage across R1 produces the sawtooth waveform, and capacitor waveform is given. And the parameters used in the UJT are intrinsic standoff ratio, which is given by eta RB1 by RB1 plus RB2, the base resistance values. So this ratio determines the peak voltage which is required to turn on the UJT. So the range of values of intrinsic standoff ratio is 0.5 to 0.8. So higher value means the peak voltage is higher. So this is the important parameter of UJT which determines the peak voltage. Let's see the advantages of UJT. So it consists of a single PN junction. So it provides a simple construction and also low cost. And due to the energy efficiency of UJT, it provides a low power consumption, and also it is a reliable triggering device since it enables the negative resistance region, and after that it goes to saturation region. It is a reliable triggering device, and due to these features it is used in the following applications like pulse generation circuits. So it cannot be used for amplifiers, but it can be used for pulse generation circuits, and also sawtooth waveform generator, and also triggering of SCR. So these are the various applications of unijunction transistor. So let's take the assessment questions. In which region of its VI characteristics UJT exhibit negative resistance? So first one, cutoff region between peak point and valley point, and saturation region and linear region. So the answer is B. Between peak point and valley point, the UJT exhibit the negative resistance. And to turn on a UJT, the forward bias on the emitter diode must be less than the peak point voltage, equal to the valley point voltage, more than the peak point voltage, 0. So the answer is C, which is more than the peak point voltage. Thank you for listening this lecture.